Now we see the next problem. Verify Caushy's theorem for the function f of z which is equal to 3z square plus iz minus 4 if c is the curve with vertices at 1 plus or minus of 5 and minus 1 plus or minus of 5. Okay, wow. So this problem directly I want to mention by using the Caushy's theorem, and function is given, that is f of z is given, but a previous problem given the circle only is asking. Okay, but this problem they asking the square. Okay, so c is a square with vertices are 1 plus or minus of 5 and minus 1 plus or minus of 5. That is real values of x value 1 and minus 1, and imaginary values of y value plus 1 and plus I and minus, that is a plus 1 and minus 1. Okay, so and vertices is given. Okay, you take the diagram, you take the x-axis and you draw the x-axis and y-axis. Okay, so have given the vertices 1 plus or minus of 5, that is x value is 1 and minus 1, that is a real values asking given plus 1 and minus 1. Okay, you draw the one straight line of x value is 1, here the counting is 1, and x dash have the negative value as the minus 1, you draw the another straight line. Okay, and next y value has the plus or minus of, that is I is the imaginary part, so that is I is the imaginary part asking given the plus and minus, so positive and negative is given. Okay, take the y-axis of value, imaginary of y values have 1. Okay, so that is here you draw this y value is 1 and one y value is minus 1, you draw the another straight line. Next you connecting this all the points. Okay, so we take the origin, center point is the origin, and next you take the, you give the points actually this first quadrant, second quadrant, third quadrant, fourth quadrant. First take the first quadrant, you give the point A, B, C, D. Okay, so A value have the this point connecting these two straight line, x value 1 and y value 1. These two point intersect the point 1 comma 1, that is x value 1, y value 1, and B value is intersected the point x value is the minus 1 and y value is a positive 1, that is a minus 1 comma 1. Okay, and C3 is intersected the point x value is minus 1, y value is minus 1, that is a minus 1 comma minus 1, you mark that minus 1 comma minus 1, take the point. Next D value is intersected the point x value has a plus 1 and y value connecting the point minus 1, that is 1 comma minus 1, D of 1 comma minus 1. First draw the x-axis and y-axis. Next axis given the vertices, real axis given plus 1 and minus 1, draw the plus 1 and minus 1, and imaginary is given the vertices plus 1 and that is y-axis given the plus 1 and minus 1. Okay, you are connecting this all points, you get the square of the vertical curve. Okay, and next you take the AB value, that is a curve C1. Okay, that is AB, this is C1, BC is a C2 curve, and CD is a C3 curve, and DA is a C4 curve. You give the C1, C2, C3, C4. Okay, so is arrow mark is very important. This curve is connecting to passing through A to B, B to C, C to D, D to A. Okay, A to B, B to C. This A to B give the curve C1, B to C give the point C2, C to D give the curve C3, and D to A give the curve C4. Okay, and next take the solution. The boundary of squares consisting of 4 curves. Because in this boundary of the curves consisting of, there are 4 curves. So in this curves like that C1, so that is a curve is like that is a lines, is like that C1, C2, C3, C4. Okay, and given the f of z is f of 3z square plus iz minus 4. You write this given the f of z value. And next, by using the formula, by the Caushy's theorem formula, integration of c f of z dz which is equal to in this curve divided the 4 curves. Okay, that is a C1, C2, C3, C4. Okay, therefore the integration of C1 f of z dz plus integration of C2 f of z dz plus integration of C3 f of z dz plus integration of C4 f of z dz. You take this equation number 1. Okay, and next first find the along C1 value. Okay, first find the along in this AB value. Okay, first find the along C1 value. So along C1 value the equation y which is equal to 1. You take this y which is equal to 1. First find the along C1, that is y which is equal to 1. Differentiation this value, that is dy which is equal to constant value become 0. Differentiation of constant value 0. Next you take the z values of complex value. Take let z equal to x plus iy. Okay, that is z equal to x plus, then to substitute the y value this equation, y value have the 1, that is I into 1 value become the I. Okay, so z equal to x plus I. Next take this z equation, this value can differentiation on both sides, that is dz which is equal to dx. It can be written as dz which is equal to dx plus I into dy. Next substitute the dx dy value. So what you got the dy answer 0. Okay, substitute this equation. Therefore the dz which is equal to dx plus I into dy value, you got the answer 0. Okay, substitute here, that is dz which is equal to d become the value dx. Okay, first to find out this, solve the condition. Okay, and next to take the line integral equation, that is integration of, first to find the integration of C1 f of z dz which is equal to integration of C1, then to substitute the f of z and dz value. F of z is given the problem 3z square plus iz minus 4. Substitute here 3z square plus iz minus 4 into dz value become the dx. Okay, so dx. So 3z into okay, you can substitute the first, after that you can substitute the dz value. First before substitute the f of z value, okay, into dz. That is integration of, since on this all the z value can replace by x or y value. Okay, so that is 3 into z value become the value x plus I. Okay, become the value x plus I. Substitute here 3 into x plus I the whole square plus I into z value, again to substitute the x plus IA, x plus IA, that is x plus I minus 4 into dz value become dx. Substitute here into dx. Okay, next in this integration value can multiplication each term. Okay, first multiplication of first term have the 3 constant I take outside, that is 3 into integration. And next before you can substitute the limits value, I don't know, actually in this equation all the terms have the variable only x variable, it not become the y variable, not become the z variable. So in this equation only have the only x variable. Okay, so here the only x variables mean we need for only x values limits along C1 value. Okay, we take this diagram along C1 value, that is along AB, that is C1 values, that is a AB lines. Okay, so AB lines we need for only x values, want to take the only x value limits. Here x value limits actually going to A to B. Okay, in this line going to the arrow mark A to B. So can take the limits value x varies from 1 to minus 1. Okay, x varies from 1 to minus 1. Okay, that is x varies from, take the 1 to minus 1, substitute here 1 to minus 1 into x vary 1 to minus 1, 3 into x plus I the whole square plus I into x plus I minus 4 into dx. And next step in this integration multiplication of each term, first multiplication of first term, the first term have the 3 constant value, first to take outside. So 3 into integration of 1 to minus 1 into x plus I the whole square into dx. And a second term have the I is a constant to take outside, into integration of 1 to minus 1 x plus I into dx. Next minus 4 is a constant to take outside, minus 4 into integration of 1 to minus 1 into dx. Okay, so all the terms you can multiplication of integration. And next using the formula, now to integration this value. So 3 into integration of x plus I the whole, already explained the integration formula. Integration of x plus a in this, suppose in this term variable adding the any constant values mean directly can integration this value. So integration of x plus a into dx value x plus a the whole square divided by 2. So give x plus a the whole square divided by 2. And one more condition and another condition. So integration this value actually is main things. Integration of x plus a into dx value x plus a the whole square divided by 2 into now to the differentiation of inside the value, differentiation of x value has a 1. Okay, you substitute the denominator only, that is 2 into 1. Suppose if for example take this equation, you take this value. Integration of 2x plus 3 into dx means directly on to integration this value 2x plus 3 the whole square divided by 2 into again to multiplication of 2x when inside the value. So give again to differentiation of inside the value. So now to differentiation of inside the value, that is again to differentiation of this value, that is 2x plus 3 differentiation this value, that is into 2 into differentiation of x value 1. Okay, 1 and to substitute the denominator value. Suppose for example we have that integration of 2x plus 3 the whole square into dx mean can write the answer 2x plus 3 the whole power 3 divided by 3 into again to differentiation of inside the value to a differentiation of 2x value as 2 into 1, this value constant becomes 0, that is 2 2s are 4. So denominator will become the not 2 2s are 2 3s are actually here the 3 into 2, that is 3 2s are 6. Okay, okay, so this for the another type of the integration. Okay, but in this condition have integration of 3 into integration of x plus I the whole square down to integration this value, that is x plus I the whole cube divided by 3 into now to differentiation this inside the value become 1, substitute the denominator only. So 3 into 1 become the 3, directly right here. Okay, x plus I by 3 the x plus I the whole cube divided by 3, the limits value 1 to minus 1. Next go to the second term, integration this value I into integration of x plus I into dx value x plus I the whole square divided by 2 into 1. So again to differentiation this value become 1. Okay, the limits value 1 to minus 1. Next minus 4 into integration of dx value has the x. So limits value 1 to minus 1. Now apply the limits value, substitute the limits value, that is and before on to substitute the limits value, and if you substitute the limits value and before to using the formula, you apply the formula a plus b. So in this condition based on the a plus b the whole cube formula. So do you know the a plus b the whole cube formula? What's the a plus b the whole cube formula? A cube plus 3a square b plus 3ab square plus b cube. This is a formula. Okay, so using this formula, so x plus I the whole cube it can be written as a cube, that is a value is like that, we have the x and b value is have the I. Okay, that is a cube, that is x cube plus 3a square b, that is 3x square into I plus 3ab square, 3 into a value have the x into b square have the I, that is 3x into I square plus b cube have the I, that is a plus I cube. Okay, so x plus I the whole cube can using this formula, and then to substitute the limits value 1 to minus 1. You taking the limits value 1 to minus 1 plus I into, you take the second term. So in the numerator value we have this based on the formula a plus b the whole square formula. So do you know the a plus b the whole square formula? A square plus b square plus 2ab. So using this formula, this is the second term. If you want to apply the second term, that is x plus I the whole square value, it can be written as I into x square, that is a square plus b square, that is I square plus 2ab, that is 2xi. Okay, so you can apply the a plus b the whole square formula. The limits value take 1 to minus 1. Next minus 4 into x limits value 1 to minus 1. Now to apply the limits value. Okay, first want to substitute the put x equal to upper value minus 1, then to substitute the lower value put x equal to 1. First want to substitute the put x equal to minus 1, that is the upper value. So put x equal to and minus, and before it's actually if you apply the limits value and before you can see this actually have the I cube I square as first you have to using this formula. Okay, after that you apply the limits value. So x cube plus 3x square into I plus 3x into I square value are the minus. So plus into minus become minus. So that is minus 3x. I cube value, you know the formula. I square value minus 1. I cube value it can be written as I square into I. Yeah. So I square value minus 1 into I become the minus. So I cube value has a minus I. Substitute here. So that is here I cube value want to substitute the minus I. Then to take the limits only 1 to minus 1. You take the second term x square I square value is here minus 1 plus 2xi. You take the limits only 1 to minus 1. Then to write the third term minus 4 into x, the limits value 1 to minus 1. Now apply the limits value. Now we go to the apply the limits value. First want to substitute the put upper value x equal to minus 1. Then to substitute the lower value put x equal to plus 1. Okay, first want to substitute the put x equal to minus 1. Okay, put x equal to minus 1. You substitute this equation. Minus 1 the whole cube value become minus 1. Okay. Here plus 3i into minus 1 the whole square value become plus 3i. Minus 3 into x value want to substitute the minus 1. Minus into minus I other plus 3 minus I. Okay, right here minus 1 plus 3i plus 3 minus. So upper value is power. Next then to substitute the lower value minus r. Lower value want to substitute put x equal to 1. Put x equal to 1 means what you get the answer 1 plus 3i into 1 square value become 1. We have 1 plus 3i minus 3 into 1 value you can write the minus 3 minus I. Okay, so minus 3 1 plus 3i minus 3 minus I. So first term over. Next go to the second term plus I into first substitute the put x equal to minus 1. So minus 1 the whole square become plus 1 minus 1 plus 2 into minus 1 can write the plus into minus 1 become the minus 2i. So upper value is over. Next, so upper values are the 1 minus 1 minus 2i. Then to substitute the lower value minus of put x equal to plus 1. Substitute the second to substitute the second term. Put x equal to 1 means 1 minus 1 plus 2i. Okay, that is you can write here 1 lower value minus of 1 minus 1 plus 2i. Next minus the we go to the last term, apply the limits value minus 4 into x value want to substitute the first upper value minus 1 lower value plus 1. So minus 1 minus of 1. Okay, that is minus 4 into minus 1 minus 1 minus of 1. Okay, that is here the cancel this value. Next you take this equation minus 1 plus 3i plus 3 minus I. Next minus value multiplication this multiplication inside the bracket minus plus into minus can write the minus 1 plus minus into plus become minus 3i. Minus into minus you can write the plus 3 minus into minus you can write the plus I. Okay, next you take the second term. Here plus 1 minus 1 cancel, plus 1 minus 1 cancel. The remaining value have I divided by actually have the x square divided by 2. Okay, have the I divided by 2. So plus I divided by 2 and plus I by 2 outside value plus I by 2 minus 2i minus minus into plus become minus 2i. So okay, minus 2i minus 2i become the minus 4i. So I divided by outside value I divided by 2 into minus 4i. And next multiplication the last term minus 4 here the minus 2. Minus 4 into minus 2 become the plus 8. Okay, so that is a plus 8. And right here I by 2 into minus 2i that is minus 4 become minus 2. So minus into minus become the plus 8. Now to simplify this value 2 2s are 4. That is minus 2 have the minus 1 we can write the minus 2 and plus 3 and plus 3 add this become the plus 6. Next plus I by 2 and okay, simplify this value become minus 2 I into I value I square value into the formula minus already have the minus into minus plus 2 plus 2 plus 8. Here minus 2 and plus 2 cancel. Finally become the answer integration of c1 f of the dz which is equal to 6 plus 8 value become 14. Okay, you take this equation number 2. Next find the along c2 value. along C2 value. Along C2 value, that is a BA. Go to the lines BA, BC, not BA, BC. Okay, this for the C2 arm. Okay, so BC value, the straight line x equal to -1. You take the along C2 value of this line equation x equal to -1. Differentiation this value dx equal to 0. And next it is the complex values of z value equal to x plus iy. Then to substitute the x value this equation, z equal to x value you want to substitute -1 plus iy. Okay, therefore the dz is, you taking this equation differentiation on both sides, dz which is equal to dx plus I dy. Okay, next substitute the dx value this equation. Therefore the dz which is equal to dx value got the answer 0. Substitute here 0 plus I into dy. So finally you can write the answer dz which is equal to I into dy. Okay, and next you take the along C2 value. Along C2 which is along C2 into f of z dz which is equal to integration of C2 f of z dz which is equal to integration of C2. Then to substitute the f of z value, given the problem 3z square plus iz minus 4 into dz. Next you can replace in this z value, you can replace by real and imaginary, you can replace by x and y variable. That is integration of 3 into z values of complex, z values of become the value iy minus 1. First I will take the positive value iy minus 1. That is iy minus 1 the whole square plus I into, again to substitute the z value iy minus 1. Iy minus 1 minus 4 into dz value, we got the answer I into dy. Substitute here I into dz value, can substitute the I into dy. Here I is a constant, you take outside, that is I into, now to integration this value I into, first to take the first term, directly can integration this value 3 into integration of iy minus 1 the whole square value iy minus 1 the whole cube divided by 3 into, again to differentiation inside the value. So differentiation of iy value, that is a I. So constant value becomes 0. Okay, so iy minus 1 the whole cube divided by 3 into, again to differentiation inside the value, that is become I. Okay, I will substitute the denominator value into I. Next we take the second term plus I into iy, integration of iy minus 1 into dy value. You write the answer. You have the power value 1, that is iy minus 1 the whole square divided by 2 into, again to differentiation the inside the value, that is iy minus 1, differentiation of iy minus 1 become the I. Okay, I have to substitute the denominator value into I. Okay, here plus numerator and denominator values of I values cancel. The first term 3 values, numerator denominator value 3 values cancel. Go to the last term. Now to integration this value, integration of minus 4 into dy value minus 4y. Okay, you take the limits value 1 y varies from, already explained, didn't explain, but you have to, actually all the terms here the only y variable, so only need for the only y values limit. You want to take the only y values limits. You take along C2 value. Now you want to see the along C2 values. Okay, so in this along C2 value, you are going to line the B to, you are going to connecting the B to C, that is a B to C mean, that is y varies from 1 to minus 1 to minus 1. Okay, that is C2 arrow mark is going to B to C, that is y varies from 1 to minus 1. I substitute here 1 to minus 1 to minus 1. So differentiation, already explained the integration. You take the limits value 1 to minus 1, y varies from 1 to minus 1. Therefore I into, here 3 values cancel, numerator denominator I values cancel, that is I into iy minus 1 the whole cube divided by I plus 1 by 2 into iy minus 1 the whole square minus 4y, the limits value 1 to minus 1. Okay, next outside values of I value multiplication, each multiplication inside the value I divided by I into iy minus 1 the whole cube plus 1 into I, can write the I divided by 2 into iy minus 1 the whole square minus 4iy, the limits value 1 to minus 1. Okay, now to using the formula, so in this first term is based on the a minus b the whole cube formula. So a minus b the whole cube formula is a cube minus 3a square b plus 3ab square minus b cube. Okay, so you can using this formula a cube. A cube means here instead of substituting a value iy and b value you can consider this 1. So a cube, that is I cube into y cube minus 3a square b, that is I square into y square into b value 1, plus 3ab square plus 3 into a value has the I into y into b square value the 1, that is a 1 square. So a cube minus 3a square b plus 3ab square minus b cube, that is a 1 is there, that is minus 1 cube. Okay, so first to using the formula. Next you go to the second term I by 2 into the second term have the iy minus 1 the whole square, so you can using the formula a minus b the whole square formula. So in the a minus b the whole square formula, a square minus 2ab plus b square, using the apply this formula. Okay, that is a square y square minus 2ab minus 2iy into 1 plus b square, that is a 1 square value becomes 1 minus multiplication of I value inside the value minus 4i into y minus 4iy, the limits value 1 to minus 1. Okay, minus 4i 1 to minus 1. Next on to apply the limits value. And before to simplify this value, that is I cube value minus I into y cube minus I into y cube. I cube value minus I into y cube. Next I square value has a minus 1. So minus into minus plus 3y square. Next multiplication this value 3iy minus 1 cube value become minus 1 plus I by 2 into I square value minus 1. Okay, minus 1 into y square minus 2iy plus 1 minus 4iy. We take the limits value 1 to minus 1. And now we want to substitute the limits value. First to substitute the upper value, put y equal to minus 1. Then to substitute the lower value, put y equal to 1. First want to substitute the put y equal to minus 1. So my y value and so minus 1 the whole cube value become minus 1. So already have the minus into minus, that is a plus I plus minus 1 the whole square has become plus 1, that is a plus 3 minus have the plus 3 into minus 1 can write the minus 3i minus 1. Next substitute the lower value, put y equal to 1 means that is a minus I plus 3 plus 3i minus 1, that is a minus I plus 3 plus 3i minus 1. So upper and lower value is over. Next go to the second term, can apply the limits value. Second term outside value have I by 2, we take outside I by 2 into substitute the upper value, put y equal to minus 1 the whole square, that is a minus 1 minus 2i into minus 1 can write the plus 2i plus 1. Next minus of put y equal to lower value 1 minus 1 minus 2i plus 1 minus 1 minus 2i plus 1. Here minus 1 plus 1 cancel and the lower value the minus 1 plus 1 cancel. Okay, next you go to the last term minus 4i into, then to substitute the upper and lower value minus 1 y value is a minus 1 minus of lower value put y equal to 1, that is a 1 minus 1 minus 1. Okay, so add this value. Actually the negative value multiplication inside the value, that is I plus 3 minus 3i minus 1 minus into minus plus I plus into minus and can write the minus 3 minus into plus can write the minus 3i minus into minus I can write the plus 1. Okay, and next the remaining value has plus I by 2 into plus 2i minus have the minus, so minus into minus you can write the plus 2i. So 2i plus 2i have the 4 plus 4i, I by 2 into 4i. Here minus 4 into can write the minus 1 can add this value, it can become minus 2. Okay, I will write the next page and to multiplication to all the values. I will write here I plus 3 minus 3i minus 1 plus I minus 3 minus 3i plus 1 plus I by 2 into 2 plus 2 become minus plus 4i plus 8i. Okay, now to simplify this value, plus 3 and minus 3 cancel, plus minus 1 and plus 1 cancel. Okay, so that is y plus I can write the 2i minus 3i minus 3 I can write the minus 6i. here I into I value I square. So I square value into the minus. Can write the minus 2. So okay, plus last term plus 8i plus 8i. So next add the terms of real part, then add the terms of imaginary part. The real term is 2 plus 8 become 10. 10 minus 6i, subtract this value. 10i minus 6i minus 2. Okay, plus 4i minus 2. So take this equation number. That is minus 2. First to take the real part, minus 2 plus 4i. You give the equation number 3. So along C2 value got the answer minus 2 plus 4i. And next we want to find the along C3 value. In along C3 value the line equation is along C3 value, this is a C3 value, C2D is a C3 curve line. So along C3 of the line equation is y which is equal to minus 1. You give us, that is a y which is equal to minus 1. We take this y which is equal to minus 1, differentiation this value dy which is equal to constant value becomes 0. You take the complex value z value equal to x plus iy, that is z equal to x, so y value can substitute here. I into minus value can write the minus I, that is z equal to x minus I. We are taking this equation differentiation on both sides, dz which is equal to dx plus I dy, that is for the dz which is equal to dx plus dy value we got the answer 0. Substitute here, I into 0 value becomes 0, that is dz which is equal to dx. Okay. Next to take the integration of C3, f of z dz which is equal to integration of C3, f of z value into the given problem 3z square plus iz minus 4, substitute the f of z value into dz. Next in this z value can replace by x or y variable, that is integration of 3 into z value have x minus I. So you can substitute the x minus I the whole square plus I into z value again to substitute the x minus I minus 4 into dz value have dx. You can substitute here dx. Now to integration this value, so actually here all the terms have the only x variable. So want to take only x values limits along C3 value. So along C3 value have the x values limits minus s, that is a C3 is that is a CD line. Okay, minus 1 to 1, minus 1 to 1. Okay, substitute here, that is minus, actually along C3 value here, minus along C3 value minus 1 to 1, y varies from x varies from minus 1 to 1. You substitute here minus 1 to 1, 3 into minus 1 to 1. Now to integration this value 3 into x minus I the whole square of integration value x minus I the whole cube divided by 3. Again to differentiation this value become 1. So 3 into 1 you can write the 3 plus I into x minus integration of x minus I into dx value, you can write the answer x minus I the whole square divided by 2 into, now to again to differentiation of inside the value 1 minus 0, that is you can write the 2 into 1, I can write the 2. So that is x minus I the whole square divided by 2 minus 4 into integration of dx value, actually integration of dx value. Now a correction here, actually have the x variables, so give a correction here. So minus into integration of 4 into dx value, you can write the minus 4x, the limits value minus 1 to 1. Okay, and that is here 3 values cancel. Okay, and next x minus I, the remaining value of the x minus I the whole cube plus I by 2 into x minus I the whole square minus 4x, the limits value minus 1 to 1. Now to using the formula a minus b the whole cube formula, apply the a minus b the whole cube formula. A cube, that is x cube, minus 3a square b, that is minus 3x square into b value have I. So minus 3x square b minus 3a square b minus 3x square into 1 plus 3ab square plus 3x into b value have the I, that is a 3x into I square minus b cube value have, that is a minus I cube plus I by 2 into second term is based on the a minus b the whole square formula. Can using the a minus b the whole square formula, a square, so that is x square minus b square. So I square value is a square plus b square. So b value is I square value can write the minus 1 minus 2ab minus 2x into I minus 2x into I. Okay, minus 4x directly take this value minus 1 to 1. Okay, now simplify this value x cube minus 3x square in minus 3x square into I. My I square value have the minus, so my plus into minus can write the minus 3x. I cube value know the formula minus I, already have the minus into minus can write the plus I by 2 into x square minus 1 minus 2xi minus 4x limits value take minus 1 to 1. Now apply the limits value. First you want to substitute, put x equal to upper value, put x equal to 1. Put x equal to 1 means 1 minus 3i minus 3 plus I. Okay, then to substitute the lower value minus r. Lower value can substitute, put x equal to minus 1. So x equal to minus 1 the whole cube value become minus 1. Minus 3 into minus 1 the whole square become minus 3 into I. Minus 3 into minus 1 can write the plus 3 plus I. So upper and lower value over from the first term. Okay, next to take the second term. Plus I by 2 into first substitute, put x equal to 1 minus 1 minus 2i minus put x equal to minus 1 minus 1 minus 2 into minus 1 can write the plus 2i. Okay, minus 4 into 1 minus 1 upper and lower value can substitute here. Okay, next to simplify this value. 1 minus 3i minus 3 plus I, negative value multiplication inside the value, minus into minus you can write the plus 1, minus into minus plus 3i, plus into minus you can write the minus 3, plus into minus you can write the minus I. Okay, plus I by 2 into plus 1 minus 1 cancel, here the plus 1 minus 1 cancel, the remaining value are the minus 2i, minus into plus can write the minus 2i, so minus 2i minus 2i can write the minus 4i, minus 4 into minus of minus 1 plus 1, so 4 into 2 value can minus 4 into 2. Now to simplify this value, minus 3i and plus 3i is cancelled, plus I and minus I is cancelled here. Here I by 2 into 2 2s are 4, simplify this value. It's okay, the remaining value. Okay, now to add this value, therefore the 1 plus 1 can write the 2, minus 3 and minus 3 can write the minus 6. Here the minus 2 into I square, I into I value can write the I into I value can write the I square. So I square value into the formula minus, already have the minus into minus plus 2, that is plus 2 minus 4 2s are 8 minus 8. So add this value, cancel this value, 2 plus 2 we can write the 4 minus 6 minus 8 become minus 14. So subtract this value, 4 minus 14 become the minus 10. So you take the equation number 4. Next find the along C4 value. Along C4 value. Now along C4 value take the diagrams, that is D2A. So along C4 value have the equation x equal to 1. Okay, you take this x equal to 1. Along C4 x equal to 1, differentiation this value dx equal to 0. You take z equal to x plus iy, z equal to x value substitute here 1 plus iy. Differentiation this of z value dz equal to dx plus I dy, dz equal to dx value becomes 0, substitute here 0 plus I dy. So finally you can write that dx equal to I into dy. And next to take the integration of C4, f of z dz which is equal to integration of C4. Next substitute the f of z value and dz value. In z variable you can replace by x and y variable. So 3 into z value has the 1 plus iy, that is 1 plus iy the whole square plus I into z value again to substitute 1 plus iy minus 4 into dz value the I dy, substitute here I into dy. Here I is a constant, take outside, I into integration of, actually here all the terms are only y values limits. So we need for the y values limits. So along C4 value, along C4 we need for the y, we want to take the y values limits. minus 1 to 1. Okay, minus 1 to d to a, that is minus 1 to 1. Okay, therefore the y varies from minus 1 to 1. Okay, substitute here minus 1 to 1. That is I into, okay, minus 1 to 1. Integration of minus 1 to 1. 3 into 1 plus I y the whole square plus I into 1 plus I y minus 4 into dy. That is I into integration this value 3 into 1 plus I the whole square value can write the 1 plus I by the whole cube divided by 3 into, again to differentiation of inside the value, this constant value 0 plus I into 1. Okay, can become the I, that is 3 into I. Substitute the denominator value 3 in this answer. Differentiation of this, that answer you can substitute the denominator value into I. Okay, so plus I into 1 plus iy, integration of 1 plus iy formula 1 plus iy the whole square divided by 2 into, you take this numerator inside the bracket, differentiation this value. Okay, become 0 plus I into 1, you can write the I. Okay, that is 2 into I. Substitute the denominator value minus integration of 4 into dy value, you can write the minus 4 by the limits value minus 1 to 1. Here first term of the 3 cancel, second term high values cancel. Next the outside values of I value, multiplication of each and every term. I divided by I into 1 plus I y the whole cube plus I by 2 into 1 plus I y the whole square minus 4 into I 4I y, the limits value minus 1 to 1. Now to using the formula a plus b the whole cube, take the first term. This first term is based on the a plus b the whole cube formula. So can using the a plus b the whole cube formula, a cube, that is a 1 cube plus 3a square b, that is 3 into 1 square into b value I y plus 3ab square, 3 into 1 b square value I square into y square plus b cube plus b cube value I cube into y cube, that is plus I cube into y cube plus I by 2 into a plus b the whole, you can apply the a plus b the whole square formula. A square, that is 1 square value, you can write the 1 plus b square I square into y square plus 2ab plus 2iy. Okay, minus 4iy, the limits value minus 1 to 1. Now substitute the limit and we can simplify this value. 1 cube value, can write the 1 plus 3, simplify this value 3iy, 3 into 1 I square value minus, plus into minus, can write the minus 3 into y square, I cube into y cube, that is I cube into y cube value minus I, that is minus I into y cube plus I by 2 into 1 y square value have the minus, plus into minus, can write the minus y square plus 2iy minus 4iy, the limits value minus 1 to 1. Now to apply the limits value, upper value are the 1, lower value minus 1. Substitute the upper and lower value. 1 plus 3i, 1 plus 3i, 1 plus 3i minus 3 minus I. Next substitute the lower value, minus of to y equal to minus 1. That is 1 minus 3i minus 3 plus minus 3 y minus 1 the whole cube value become minus, so minus in the minus you can write the plus I plus I by 2 into 1 minus 1 plus 2i minus of lower value put x equal to minus 1, 1 minus 1 minus 2i, 1 minus 1 minus 2i, plus 1 minus 1 cancel, plus 1 minus 1 cancel. Here my negative value, outside values of negative multiplication of inside the value, 1 plus 3i minus 3 minus I minus 1 plus 3i plus 3 minus I. Right here plus I by 2 into plus 1 minus 1 cancel, 2i minus into minus plus 2i, that is a 2i plus 2i minus 8i. Okay, minus 8i. Here plus 1 minus 1 cancel, minus 3 and plus 3 cancel. Okay, remaining value 3i plus 3i, you can write the 6i minus I can write the minus 2i plus I by 2 into 2i plus 2, you can write the 4i. So 2 2s are 4. Okay, minus 8i. Okay, you can write the minus 8i. So 6i minus 2i. I square into I value I can write the I square formula minus here the plus into minus. The remaining are the 2, that is a minus 2 minus 8i. So 6i minus 2i, subtract this value, 4i minus 2 minus 8i. Again to subtract the imaginary part, 4i minus 8i become minus 4i minus 2. You take this equation number 5. So all the 4 curves is over. C1, C2, C3, C4 is all the values found out. So in this value you can substitute from equation number 1. Next you take from equation number 1 the equation 2, 3, 4, 5, substitute in equation number 1. Okay, I take this from equation number 1. Integration, what's the equation number 1? Integration of this equation, this is a equation number 1. So integration of C, which is equal to C1 plus integration of C2 plus integration of C3 plus integration of C4. You can substitute all the values. So integration of C1 value along C1 value got the answer 14, substitute here, and 14 substitute here. That is 14. And integration of C2 value got the answer C2 value along C2 value 4i. This is C2 value minus 2 plus 4i. I substitute here minus 2 plus 4i, minus 2 plus 4i. Next along C3 value got the answer minus 10. So this along C3 value integration of, actually this is along C3 value minus 10. From equation number 4 is minus 10. I substitute here minus 10. Next thing from equation number 6, 5 is my along C4 early minus 4i minus 2. Substitute here minus 4, minus 4i minus 2. Here plus 4i and minus 4i is cancelled. So finally you can write 14 minus 10 minus 2. That is a 14 minus 14 become the 0. So actually what's the statement of Caushy's theorem? So you want to prove the statement integration of C f of z dz which is equal to right side value, we get the answer 0, but in our proof answer right side value become, we got the answer 0. So hence the theorem is verified. So this answer is 0. So this theorem is verified. And next you see the homework problem. Show that next I give the homework problem. Show that integration of C z plus 1 into dz which is equal to 0. So this problem show that integration of C z plus dz which is equal to 0. That is here. This problem is not mentioned that what theorems, but you can identify this here Caushy's theorem. Why you can say this Caushy's theorem in, that is integration of C f of z dz equal to right side value can prove the 0. So this is a Caushy's theorem. You want to use it the Caushy's theorem where C is the boundary of the square. See, then this curve is the boundary of the square whose vertices are the points z equal to 0, z equal to 1, z equal to 1 plus I, z equal to plus I. As the real values of x value in the z value, x value 0 and 1. And imaginary values of y value plus 1 is not given the negative value. Okay, or verify Caushy's theorem for the function f of z equal to z plus 1 where C is the boundary of the square whose vertices are the point z equal to 0, z equal to 1, z equal to 1 plus I, z equal to I. Okay. I give the only hint, only I explained. You do the homework problem. This can verify right side will be get 0. Okay, so I give the first you draw the x axis and y axis. Okay, you take the x axis and y axis. You take the x axis and y axis. So what is given the point z equal to 0, that is origin is given, that is z equal to 0 to z equal to 1, the real values of x value 1, that is z equal to 1, you draw the one x straight line x equal to 1, okay, this for the x equal to 1, and z equal to 1 plus I, imaginary values of y values have the 1, okay, so y values have the 1, okay, you draw the another straight line of y axis. okay, but not given the imaginary of y value, okay, not given the negative value, so only are given the positive values given imaginary part. So z equal to 0, z equal to 1, z equal to 1 plus I, that is z equal to 1 plus I, 1 comma 1, z equal to I, that is a 0 comma 1, okay va. You give the point O, A, B, C, that is a OA value, give the curve C1, AB value give the curve C2, next B to C, that is a C3, C to O, that is give the point C4, okay va, C1, C2, C3, C4. So arrow mark is very important, okay va. Along OA value, so actually this for the x-axis will take the y which is equal to 0. So along C1 curve the equation is y which is equal to 0. Along C2 curve is the equation is x equal to 1. This for the x equal to 1 straight line equation, and this for the y equal to 1 straight line equation. So give x equal to 1. Along C3 curve line equation is y equal to 1. So x axis and y equal to 0, and y axis you take the x equal to 0. Along C4 is the line equation is x equal to 0. You take this x equal to 0. Okay, I give the hint only, I explained, you do the homework, and then given the answer, C1 value 3 by 2, C2 value 2i minus 1 by 2, C3 value minus of 3 by 2 plus I, and C4 value 1 by 2 minus I. So add this, all the 4 values become 0. Okay, and second problem, I give the homework problem. Verify Cauchy theorem for the integral of z cube. So f of z is z cube given, taken over the boundary of the rectangle. So in this curve given the rectangle with the vertices minus 1 comma 1, 1 plus I comma minus 1 plus I. So x value is real value is given plus 1 and minus 1, and imaginary of y values only plus 1 is given, only I plus I only is given, not given the minus I. So it's very important of this point. Okay va. How draw the diagram? Draw the x-axis and y-axis, okay va. So in this real axis given plus 1 and minus 1, I take the x value is 1 and x value is a minus, and draw the one straight line here and one straight line, the another negative, x equal to minus 1. So x equal to 1 to x equal to minus 1, you draw the two straight line, okay. And then draw the another y values have the high, that is the y coefficient in the 1, that is draw the straight line and the straight line y which is equal to 1, okay. So connecting this point, you give the point O, A, this first one A, B, C, D, okay, C1, C2, C3, C4. The C1 curve is, the C1 curve of the equation is y which is equal to 1, and the C2 curve of the line equation is x equal to minus 1. You can substitute the x equal to minus 1. Along the curve of C3 line equation is this x-axis. X-axis means you can take, so x-axis means you can take the y which is equal to 0. That is along C3 curve line equation is y equal to 0. Next you want to find the along C4 the line equation is, you want to take x equal to 1. Okay, and using the all the line equation, then to get the value, C1 value get the what the answer 0, C2 value get 5 by 4, C4 value get minus 5 by 4, C3 value get 0. Okay, so you can verify all the values, okay, right side value becomes 0. So in this theorem is also verified that you can verify is it is verified, see Cauchy's theorem or not. Okay, you do these two problems.